Welcome and hello. This is a video exercise in MODSIM, and in this exercise, we're going to be dealing with water rights. All right, so we're going to use the water rights extension, which is up here in MODSIM extensions, water rights extension. There it is. Before we get going with that, I'm going to click cancel. We're going to build the network, add some data, and then add the water rights data and run the simulation. All right, so let's go ahead and get started. Being an exercise, I'm going to start from the very beginning. That involves adding the components to the map. So I'm going to start with a non-storage node. Boom. I'm going to call it NS0. This will serve as the location for inflow in the network. I'm going to add a few more non-storage nodes here, specifically 4. So we're going to go with an NS1, NS2, NS3, and then that's 4 total. Yeah, and then a network sync, which will be right here. Okay, let me go ahead and label these. So this will be NS1. All right, off camera, I labeled the non-storage nodes. Now I'm connecting them together, trying to. Here we go. All right, now I'm going to add some demand nodes. These are consumptive demands. So with each non-storage node, 1, 2, and 3, I'm going to have a demand node, D1, 2, and 3. There's D2, there's D3. Go ahead and label those, and then let's get those connected, just like so. You just drag and boom. All right, we have our network built. It's ready for some data now. At the upstream end, I mentioned this is where our inflow is going to be. So I'm going to right click properties. And then when the properties dialog box pops up, here is where I define the inflow to this non-storage node. Now, before I forget, I actually want to set the date range for this simulation. It's going to be a 3-year simulation I'm going to run, and it's going to be on a 1-month time step. Make this pretty. All right, I'm going to click on MODSIM Network Settings, and then in this dialog box in the Time Step tab, the 1-month time step is good. We don't need to change that. But then for the data end date and simulation end date, I want to extend that 2 more years because the default right here is set for just 1 year, the year of 1980. So instead of 1981, I'm just going to say 82, 83. Okay. So we have 1983 selected here for data end date. Simulation end date, I can now select the data end date, which is right here. All right. So this is going to be for 1980, 1981, and 1982, those 3 years. I'll click apply, then OK. Now we can go back to our non-storage node 0, open up the properties box, and then I'm going to check this checkbox right here, varies by year, which means the data that I enter will be different for each year. Okay, yes. And also I see the year listed out here in the month/day/year format. I've got some data copied onto my clipboard from Excel off the camera. So I'm going to go right click and then paste column. And as you can see, here are our values for the inflow in units of acre feet per month. They just steadily increase by 500 acre feet per month. If I click on the plot, you can see what that looks like. It's just a constant increase. Then if I click on the bar plot option, you can see that it is discrete increases once every month. Okay, so I'll click apply and OK. Next, what we need to do is input data for the demand nodes, D1, D2, and D3. So I'll go ahead and do that now. Let's start with D1 and open up the properties box. Let's move that over here. And then for the general tab, I'm not sure why it doesn't open up at general tab, but for the general tab, I just wanted to point out the default priority number of 100. I'm going to leave it at that. And it's going to be the same for all 3 demand nodes, D1, D2, and D3. They'll all have a priority of 100. So I don't have to say it all 3 times. Okay, for the time series, I'm going to use a constant demand for the entire simulation. And for D1, that demand is going to be 3,900 acre feet per month. I'll click apply, click OK. And then for demand D2, again, this is going to use the same priority of 100, but for the time series, this is going to be 6,000 acre feet per month. Apply, OK. All right, the last demand is D3, right click, properties. And then for the time series, I will say 4,100 acre feet per month. So that's going to be a constant demand for each of these 3 demand nodes for all 3 years of the simulation. Apply and OK. All right, next we need to actually activate that water rights extension, which I mentioned earlier. I go up to MODSIM and then extensions, And then the third extension here is the water rights extension. Go ahead and check that checkbox, click apply, and then click OK. Before I forget, I also want to save the model. So File, Save, and then navigate to where I want to save this. Yep, in my project directory. We could just call this exercise 18, and we're good to go. All right, the last thing we need to do before running the model is actually create the water rights. And we've made that possible by invoking that water rights extension right here, because we have this new water rights control dialog box. Now, I'm not going to use this dialog box as I build out my water rights. I'm going to do so manually in the actual link itself, the more traditional link properties editor box. But we can return to this dialog box at the end to show you what it would look like had we created the water rights using this dialog box. All right, so let's start with how about demand D1? So the link to demand D1 is from NS1 to D1. So the water rights is really associated with a link, not so much a node. I'm going to go right click on that link. And then the first thing I want to do is convert to multi-link. And the reason I'm doing this is because the water rights are a little bit more complicated than just top priority, second priority, third priority. What I have in this Excel file here outlines the priorities for demands D1, D2, and D3. As you see, each of these demand nodes have multiple water rights, and then they're in this particular priority rank. I've labeled the priority rank and ordered this table based on priority rank number. So the very most important water right, the most senior water right is this first one here, and that is a total of 2,400 acre feet per month going to demand node D3. So I'm just setting the rights date to 1980 and the cost of -500. As you notice, these rights dates increase and then the cost also decreases, or sorry, it increases. It becomes a smaller negative number. All right. I've also added this arbitrary letter just for me to use for labeling purposes because the number is sometimes gives the multi-link a little problem. I'll show you what I'm talking about in just a moment. All right, so go ahead and screenshot this table if you want to follow along and use my exact numbers. Otherwise, I'll do so on the screen. All right, so let's go ahead and convert to multi-link. Boom. Now I'm going to use this first link within the multi-link for my highest priority for demand node D1. And that's going to be priority B with a flow of 1800. And let me just start typing in the data. So I'm going to select that record, click on edit link. I don't need to create a new link because the multi-link automatically starts me off with one link. All right, so for the name, I'm going to keep it with NS1 underscore D1, but I'm also going to add a dash B at the end. Now this dash B refers to this right here, this B letter. So for demand node D1, I've color coded it as well. It's going to have this water right and this water right down here, referring to rank 2 and 6 or identification letter B and F. And then they'll have costs for -450, -250 for total allocation of 1,800 and 2,100. All right, so that's what we're going to be doing with demand node D1. So I've got the label done. Next down, I want to make sure I change the link type here to natural flow. And then for the link cost, that's going to be -450. The minimum flow is 0, that's correct, but the maximum flow is going to be set to that particular allocation, which in this case is 1,800. And then for the date, the water rights date, I'm going to set that to 1981 and then click apply and click OK. All right, so this link, the first link in the multi-link for demand node D1 is done. I'm going to create another one now. This is going to be for water right F. So click a link, and then here is the data. Here's the name at the top. And what I was talking about being a problem, doing an underscore number is sometimes a problem. So if I did like a number underscore 2 or number underscore 3, or maybe even 1, that could also be a problem. So I'm just going to get in that habit of doing a dash. And then in this case, I'll go with the letter, specifically F. All right, again, link type, I'm going to switch that to natural flow. And then the link cost, I'm going to change that to -250. The minimum will be 0, that's correct. And then the max capacity of that link, I will set to the allocation value, which is 2,100 according to my table. And then the date I have for 1985. Apply, okay, apply, Okay, I'm done with my multi-link demand node D1 that has two water rights. I need to do that process two more times now for demand node D2 and D3. So I'm going to record the whole thing and show it all, but it's going to be at sped up a little bit. So feel free to use my numbers if you want. Otherwise, I'll see you in a bit. And 1986. Okay, so that's the last water right date of the last link within the last multi-link, which was demand node D1. Oops, I need to change this link name real quick. Just the dash G at the end. I think that's safe. Okay, apply. All right, click OK. Now I mentioned looking at that water rights editor box. Let's see what it looks like now that we have all of our water rights added manually via the natural link type, MODSIM, and then water rights control. All right, so here is that table. This is a good way to kind of review my work. So I can just view the link names. That looks good. Water rights dates, the amounts, costs. Yeah, make sure they're all negative. And then I can also sort. So for instance, if I wanted to sort by the water rights dates, this is the order of priority. Here the names are ordered, what A, B, C, D, E, F, G. And I can just confirm that these numbers here match up with the numbers in my Excel file. So here are this list of allocation values should be the same as this list right here. Yeah. Okay. Well, looks good. I think we're ready to run the model. So without further ado, apply. Okay. One more time with saving it and then run MODSIM. Click OK. Now what I want to do for my results is I want to view the node data first. I think that's a little more satisfying because it combines all the link flows. So I'll go up to MODSIM graphing mode. This just makes it a little bit easier to grab the data I want. I'm first going to click on demand node D1, then I'll minimize that, and then D2 and D3. Okay, let's bring up those results now. Here is our table. Okay, I've toggled off everything except the surface inflow from each of these demand nodes, D1, D2, and D3. It looks a little funny because of the bar style. Let me switch that over to line. Okay, that looks a little better. So let's see here. Blue, D1 is blue. D2 is the light orange, and then D3 is the darker orange, or you might call it red orange. And you can see that the amount of water delivered to each of these three demand nodes increases as the water availability in our NS0 inflow node increases. And since that inflow increases linearly, we could also just say this horizontal axis is the flow rate as well. Starting off at, I believe it was 1,000 acre feet, which is what all goes to our red one. That's D3. And then once that gets up to 2,400 acre feet per month, then it looks like the blue line, that's demand D1. It starts getting some of its allocation filled for that first water right. And then D1 gets its second water right satisfied later on in the simulation once the flow rates become higher. So that's that plot there. Instead of surface inflow, I'm going to toggle on the shortage now. So this is the shortage for demand one. This is the shortage for demand two, and this is the shortage for node D3. I just realized, and it probably took too long, but whichever series of data I'm selecting over here in the legend, then that's the one that's highlighted on the plot. But yeah, it looks like by the, let's see, early 1982, about April 1982, I think this is at about 14,000 acre feet of per month of demand flow. Then that's when all of the demands for this hypothetical scenario have been satisfied. But we can also trace what is the shortage at any time, or rather any flow rate, based on the demands and the water rights and those priorities. Let's go ahead and pick on D3 one last time here. So I have D3 showing up on the plot here. This is our one demand that has three water rights associated with it. And you can see it's one, and then has to wait, and then two, and then has to wait for more water, and then three. And I point this out because these three individual allocations can be seen if we look at the plot for the multi-link. So I'm going to close the D3 demand node plot and then bring up the multi-link. And boom, here it is. But let's see. So flow, no, that's the last one. That's G. Here's A. This is the very first water right of the entire system. And then here's D. It's the fourth water right of the entire system. That's the light orange, I believe. Yeah. But it's the second water right for this demand node D3. And then finally G, that's blue. That's the seventh and last water right, the final, the most junior appropriated water right within the system, and third and last to demand node D3. This was more of a hypothetical exercise simply because the inflow data looked rather contrived, where it was just a constant line straight up. But what I'm going to do now in the 3 years of data is paste in some more realistic looking inflow data. So I have it on my clipboard already. I'm going to go paste column. Here's some numbers, but let me open up the plot. And you can see that we have 3 years of wet period, dry, wet, dry cycles between the years. We have an average year, a wet year, and then a dry year. So let's go ahead and just use these numbers with the existing demands and water rights in place and see what we get. So I'm going to click apply, save that data, and then click OK. Let's go and save the model and then MODSIM, run MODSIM, and OK. All right, that finished up. Let me make sure I'm on graphing mode. I am. Okay, so I'm going to click on D1, going to minimize that, D2, and D3. Got to get D2, D2. All right, so here is the demand data with this new inflow. Okay, so I have the surface inflow showing right here. And let me go ahead and change the bar style to line style. That looks a little better. It looks like we have a well-defined wet and dry period because you can see that this part, and this part of the plot, the lines are higher. There's more water allocated to our demand nodes D1, 2, and 3. And then we have peaks and valleys. The valleys would be the drier part where there's less inflow available. We can also tell that just by the length of the line where it tops out at the maximum value, that there's the medium year, the average year, we'll call it, a wet year, and a dry year. Definitely a major drop right here in the amount of water delivered to this. This is D2. And I think this is also reflected in the shortage. So let's take a look at the shortage plot. I'm going to toggle off the surface flow, toggle on the shortage for all three of our demand nodes. Yep, and sure enough, this is D1, this is D2, and then this is D3. Okay, I like that. So D2 looks pretty severe right here. We have more than 5,000 acre feet per month of shortage in the dry part of the dry year. Hypothetically, we could change the water rights and the data right here with regard to the priorities based on the costs. So here's D2. It looks like its third priority getting 1,200 acre feet per month, and its fifth overall priority is getting 4,800 acre feet per month. But say, for example, demand node 2 spoke and negotiated with demand node D3. D2 and D3 talked, and D3 is going to allow D2 to take an additional 1,800 acre feet per month before it gets its 1,000 acre feet per month. And then it would also have to give up the 1,800 acre feet per month down here at priority ranking 5 or E to make it fair for everyone downstream and not have to negotiate with them. So let's go ahead and just add 1,800 to this number. 1,200 becomes 3,000. And then removing 1,800 from 4,800 would also make it 3,000. So it's the same 6,000 acre feet demand node D2 is allocated, except it just increased its priority with negotiating with D3. Okay, so let's go ahead and make those changes in the model and rerun the model and hopefully get less shortage right here. Just a sort of a scenario worth trying. So what I need to do is open up the multi-link going to demand node D2. Here it is. And then let's start with the first one. This is C. And I click on edit link. And then what I need to change here is just the maximum value. So it was 1,200. I'm going to change that to 3,000. That's in acre feet per month. Nothing else needs to change. So I'll click apply and OK. And then the other water right, E, right here, I'll click on edit link. And then I need to reduce the max capacity, which is the allocation is now 3,000 just as well. Apply, OK, and then apply OK. I'm going to go up to MODSIM and click on Water Rights Control just to make sure that that was saved. Yep, there's 3,000 there. There's 3,000 there. I could have actually just made that edit in this box because this is editable, but the change is already made and saved. So I'm going to click Cancel and then save the model and then MODSIM, run MODSIM, and then click OK. All right, so that ran. Let's take a look at our demand nodes one last time. I'm going to toggle on the graphing mode. I toggled it off earlier. Here is D1. Let me minimize that. D2. Okay, I clicked it this time. And D3. Let's bring up those plots. Okay, this is the surface inflow using the line style plot. And it looks a lot the same as it did before. Let's look at the shortage now for each of our 3 demand nodes. And here is the shortage for node D2. It's still above 5,000 acre feet per month. So apparently the change that we made didn't fix the problem or reduce the shortage for the dry period of the dry year. But that's why we have computers. We can very quickly and easily model those sorts of simulations and figure out what the demand node D2 needs to do to reduce their shortage in this situation. All right, well, that was it for us. And for this exercise, we looked at water rights in a MODSIM simulation by using 2 different inflows and 3 different demands with a total of 7 different water rights.